It's time for another math easy solution. Trying to discuss integrals and areas between curves. Yeah, earlier I went over areas that lie under a curve or function, but here I'll go over areas that lie between two curves or functions. Yeah, for example, if let's consider these two functions. Let's call this one f of x, and now let's call this random one g of x right here, and let's say we wanted to know the area under basically in between these two curves, or this entire area or region we'll call S right here. Yeah, and these lie between these vertical lines at x equals b, and this is at x equals a right here, and this is x equals b. Yeah, and now from this curve, it's fairly obvious that we can write the sum or the area in between as a Riemann sum, like I went over in my earlier videos. Basically, in this case, we just have to draw rectangles across this area. So yeah, if we were to draw a generic one right here, we'll just draw it in the center here. Yeah, actually I'll just change the color of it instead. Use red right here, and let's just draw this with the right endpoint connected to it. So this point right here, and basically if we draw in the center here, I'll just do this generically xi and then put a star on top. Yeah, now this xi star, this is just denotes it could be anywhere. We could either decide left endpoint or right endpoint or center, etc. And then as you can see, this height right here, if this was f of x, this would be f of x I star. And then this bottom one is going to be, well, f of x g of x. This is a difference. Yeah, this is actually a negative g of x I star, and the reason why it's negative is because when you plug in g of x right here, it's going to be a negative value since it's less than 0, but we want a positive one, so this is negative of the g of x, which is going to be negative. So then this full distance we are able to capture, and basically, yeah, this is our g of x. And then the full length is going to be all the way across like this, and this is simply this is the addition of these two, f of xi plus negative g of x I star, or we could write it as a difference, so f of xi star minus g of xi star. And then this difference right here is just delta x right here. And then basically when you draw more of these rectangles, as I've done right here, as you can see, it's a rough estimate of the area, and this is the Riemann sum. So basically what we could do is write this out as or the area, and we know that this is becoming basically closer and closer to the actual area as you make an infinite number of these basically of these rectangles. And so basically we could write the area as equaling to the limit as n, or the number of rectangles goes to infinity, of the Riemann sum I equals we'll call it 1 and up to n of, this is now the difference. We have to basically the area of each and every rectangle. It's going to be, and that's just going to be, well, the area of rectangles is width times height, and that's just going to be f of x I star minus g of x I star, like that's the height of the rectangle. Multiply this out by delta x. And now, as you can see, it's straightforward that this is the same thing as the definite integral of f minus g. Yeah, and I've gone over the proof of a definite integral, or the definition of it, in my earlier video. Basically, yeah, so we could write this down, and then basically put all this together, we get the area definition between the two curves. Yes, and to sum up, the basic definition is the area of the region bounded by the curves y equals fx and y equals g of x and the lines x equals a and x equals b, where f and g are continuous and f of x is always greater than or equal to g of x for all x in a and b, is basically a equals to the integral, the definite integral from a to b of f of x minus g of x, and then this is just dx, where the difference now is this is the delta x has been changed to dx right here, which is infinitely small. And there is our definition. Yeah, and notice that when we have the case where g of x equals to 0, then this basically goes back to the just the old definition of the definite integral for area under a function ab f of x dx. That's just the old definition. Yeah, and also when we have, let's say, a case where f of x and g are both greater than or equal to 0, you'll have something like this, where for example this is f of x, and then let's say this is g of x, and this is basically the area of under f of x, then minus the area under g of x right here. So this is, and we'll call this, or just highlight this out, and this is the S region which we wanted to get, and this is basically this total area minus this one right here. Anyways, that's all for today. Hopefully you'll learn from this video. I will go into examples in later videos, so stay tuned for that. And I will also be working on making these notes available to download, so check the video description below if they're not there and you want it. Just message me. I'll be working on that. Anyways, thanks for watching, and stay tuned for another Math Easy solution.